The low voltage readings, lack of response from the solenoid and test lights, and the indication from the inductive test stick suggest that the grounded wire is indeed open. Possible causes include firstly, a loose or broken connection in a junction box or outlet, secondly, damage to the grounded wire in the wall or ceiling, and thirdly, corrosion or oxidation of the grounded wire. Running a new circuit with properly grounded outlets is the safest and most reliable solution. This will ensure that the outlets are properly grounded and prevent any potential electrical hazards. Here are steps for running a new circuit. 1. Install a new circuit breaker or fuse in the electrical panel. 2. Run new NMB, which is Romex, cable from the panel to the bedroom. 3. Use a fish tape or wire puller to guide the cable through the walls or ceilings. 4. Install new junction boxes where necessary. 5. Connect the new cable to the outlets, ensuring that the grounded wire is properly secured. 6. Test the new circuit to ensure proper operation. Additional considerations include firstly, if the knob and tube wiring is in otherwise good condition, it may be possible to install a ground fault circuit interrupter, which is GFCI, outlet on the existing circuit to provide some level of protection against electrical shocks. Secondly, consider using a whole house surge protector to protect your electrical devices from voltage spikes. Thirdly, seek professional assistance if you are not comfortable working with electrical circuits. When installing a new circuit, safety is paramount. Before beginning any electrical work, turn off the power to the circuit of the main electrical panel. Use a voltage tester to confirm that the circuit is de-energized before touching any wires. Wear appropriate personal protective equipment, including safety glasses and insulated gloves. Always follow the National Electrical Code, NEC, and local electrical codes. Select the correct size circuit breaker for the new circuit. This is determined by the ampacity of the wires and the load that the circuit will be carrying. For example, a 15 amp circuit breaker requires 14 American wire gauge (AUG) copper wire, while a 20 amp circuit breaker requires 12 AWG copper wire. The new NMB cable should be sized appropriately for the circuit breaker. Ensure that the cable is long enough to reach from the electrical panel to the outlets, with some extra length for connections. When running the cable, avoid sharp bends and protect it from physical damage. Use cable staples to secure the cable to studs or joists every few feet. Install new junction boxes at each outlet location. The junction boxes should be sized appropriately for the number of wires that will be connected inside. Ensure that the junction boxes are securely mounted to the wall or ceiling. When connecting the wires to the outlets, use wire connectors that are appropriate for the size and type of wire. Connect the black wire to the brass terminal, the white wire to the silver terminal, and the bare copper or green wire to the grounding terminal. Ensure that the connections are tight and secure. After completing the wiring, test the new circuit to ensure that it is working properly. Use a multimeter to measure the voltage at each outlet. The voltage should be approximately 120 volts. Use a circuit tester to verify that the outlets are properly grounded. If the circuit is not working properly, recheck the wiring and connections. If you are unable to resolve the problem, consult with a qualified electrician. Ground fault circuit interrupter (GFCI) outlets are designed to protect against electrical shocks. They work by detecting small differences in current between the hot and neutral wires. If a difference is detected, the GFCI outlet will trip and cut off the power to the circuit. GFCI outlets are required in areas where there is a risk of exposure to moisture, such as bathrooms, kitchens, and outdoor locations. Consider installing a GFCI outlet on the existing knob and tube circuit to provide some level of protection against electrical shocks. A whole house surge protector can protect your electrical devices from voltage spikes. Voltage spikes can be caused by lightning strikes, power surges, or other electrical disturbances. A whole house surge protector is installed at the main electrical panel and will protect all of the electrical devices in your home. Seek professional assistance if you are not comfortable working with electrical circuits. The electrical work can be dangerous, and it is important to take the necessary precautions to protect yourself from electrical shock. If you are not sure how to do something, consult with a qualified electrician. Addressing the specific situation of an open ground in a knob and tube wiring system requires a systematic approach. Firstly, understanding the symptoms is crucial. The symptoms described to include low voltage readings, non-responsiveness of solenoid testers and test lights, but activation of inductive test sticks. These symptoms strongly suggest a compromised or broken ground connection. The low voltage readings indicate that there's a significant impedance in the circuit, preventing the full voltage from reaching the outlets. The solenoid tester and test lights require a certain amount of current to flow to operate. The fact that they don't light up indicates that the current flow is severely restricted. Inductive test sticks, on the other hand, detect the presence of an electromagnetic field around a wire, which can still be present even with a poor ground connection. Secondly, identifying potential causes is necessary. Possible causes include firstly, loose connections at junction boxes or outlets. Secondly, damage to the grounded wire itself, either within the wall or ceiling. And thirdly, corrosion or oxidation on the grounded wire, especially at connection points. Given the age of knob and tube wiring, these are all plausible scenarios. Corrosion and oxidation are common problems in older wiring systems, particularly in damp or humid environments. Thirdly, suggesting a solution is critical. The most reliable solution is to run a new circuit with properly grounded outlets. This eliminates the uncertainties and potential hazards associated with the old wiring. It's important to use modern wiring methods and materials that meet current safety standards. This includes using NMB, Romex cable and properly grounded outlets. Fourthly, detailing the steps for running a new circuit will help. The steps for running a new circuit involve firstly, installing a new circuit breaker in the electrical panel. The size of the breaker should be appropriate for the intended load, typically 15 amps for general lighting and receptacle circuits. Secondly, running new NMB cable from the panel to the bedroom. The cable should be sized according to the breaker size and the length of the run. Thirdly, using a fish tape or wire puller to guide the cable through the walls or ceilings. This requires careful planning and execution to avoid damaging the existing structure. Fourthly, installing new junction boxes where necessary. Junction boxes should be accessible and properly sized for the number of conductors they will contain. Fifthly, connecting the new cable to the outlets, ensuring that the grounded wire is properly secured. The grounding wire should be connected to the grounding terminal on the outlet and to the grounding bus bar in the electrical panel. Sixthly, testing the new circuit to ensure proper operation. This includes verifying the voltage, polarity, and ground continuity at each outlet. Other considerations should include firstly, ground fault circuit interrupters, GFCI. If replacing the entire circuit is not immediately feasible, installing GFCI outlets can provide an added layer of safety. GFCI outlets detect ground faults and quickly interrupt the circuit, reducing the risk of electric shock. GFCIs are particularly important in areas where there's a risk of moisture exposure. Secondly, surge protection. A whole house surge protector can protect electronic devices from voltage spikes. Surge protectors should be installed at the main electrical panel to protect all circuits in the house. Thirdly, professional assistance. If not comfortable working with electrical circuits, it's best to seek professional assistance from a qualified electrician. Working with electricity can be dangerous, and it's important to take all necessary safety precautions. When diagnosing the problem, consider that knob and tube wiring lacks a dedicated grounding conductor. Relying on the neutral wire for grounding can be problematic and unsafe. This is one of the main reasons why replacing the circuit with a modern grounded circuit is recommended. Also, the age of the wiring should be taken into account. Knob and tube wiring is often very old, and the insulation can become brittle and cracked over time. This can increase the risk of short circuits and fires. Therefore, even if the wiring appears to be in good condition, it may still be a safety hazard. When running the new circuit, pay close attention to the wiring methods and materials. Follow all applicable electrical codes and regulations. Use approved wiring connectors and ensure that all connections are tight and secure. Avoid overloading the circuit. The total load on the circuit should not exceed the rated capacity of the circuit breaker and the wiring. Consider the future needs of the circuit. Install enough outlets to meet current and future needs. Also, consider installing dedicated circuits for high-power appliances. Be mindful of potential hazards when working in older homes. Asbestos, lead paint, and other hazardous materials may be present. Take appropriate precautions to protect yourself from these hazards. When working with knob and tube wiring, it's important to avoid disturbing the existing insulation. The insulation is often made of asbestos, which can be harmful if inhaled. If the insulation is damaged or disturbed, it should be properly contained and disposed of. Document all work that is performed. Keep a record of the wiring layout, the circuit breaker size, and the date of installation. This information will be helpful for future maintenance and repairs. When replacing outlets, use tamper-resistant outlets, especially in homes with young children. Tamper-resistant outlets have internal shutters that prevent objects from being inserted into the slots. After completing the work, thoroughly inspect the area to ensure that there are no loose wires or other hazards. Clean up any debris and dispose of it properly. Consider having the electrical system inspected by a qualified electrician. A professional inspection can identify any potential problems and ensure that the electrical system is safe and up to code. Remember that electrical work can be dangerous, and it's important to take all necessary safety precautions. If you are not sure how to do something, consult with a qualified electrician.